All right. Hello, everyone. Today we are going to go through a very simple curation-focused example of how to create an SSSOM mapping file based on this tutorial that we wrote in the last months. So this tutorial is basically, so you can find it here. Someone can share the link, and I think it was Sarah shared it also in the email. It will, so the structure of this tutorial is, so you have a bit of background initially, just some basics. We looked a bit around on YouTube and to see whether we can find some, like, some kind of nice tutorials that give a bit of background on, like, the ontology alignment, on ontology matching and ontology mapping problems. These are not necessarily required to understand this project, but it helps definitely before diving into building your own first mapping set. So in particular, I would just recommend to look at this very first one. I think it's just useful for everyone to browse through it at least once. Okay, so let's start a bit then. So the first question that we need to just get all clear in our minds is the question of what kind of thing are we actually mapping when we are building mapping. So here in SSSOM, we are concerned with mapping entities like classes, individuals, and we can even map properties one to each other. But we are also concerned with mapping entities in databases, such as, for example, a specific person in a person table of a relational database. Or we can even map things like a value in the slot of a data model, like, for example, the university constant in the highest degree enumeration of some demographic survey data model. Or, and this is one of the things that we do in the clinical modeling very often, a specific code from a code system or a terminology such as ICD-10-CM. So not only can we map entities from each of these to the same kinds of system, but we map between them. So we map from classes in an ontologies to terms in a terminology, or from classes to IDs in a database, all of this kind of all of these cross-links. So we map. So that's kind of the things that we are mapping together. So these information entities, or these classes and database entities, they represent real-world objects like diseases or kinds of vegetables or concrete instances of vegetables. And we will look at some of the examples. So the example that we are discussing here is about that we've chosen to use here is for apples, and we will see how this will look like then concretely. Another thing that is very important here is inside of a mapping, we have like three entities that are of specific relevance. So we have the subject. This is the source of the mapping. So the one side of the mapping, the subject could be, for example, like a class in an ontology, as I said before. Then we have an object. So this is the entity that the subject is being mapped to. And then we have a relationship. So what we call the semantic mapping predicate, such as SCOR's exact match, or many others like obo has dbxref, or many others that you've probably all used in the past. And these are the relationships that are used to map the subject to the object, and they define the semantics with which these are mapped to each other. In SSSOM, so in particular in these tables that we are building, in these SSSOM tables, so in SSSOM, let's say, is a metadata model, and it doesn't really care so much about specific aspects like whether some identifier is a query or a URI. But when we talk here in the context of this tutorial, we will talk in particular about curating mappings in these SSSOM tables, which is probably the representation that most of you are most familiar with from what you've seen so far. And we will look at some examples in a second. And in this table, we generally refer to any kind of entity using compact URI syntax, or query syntax. So you've seen this word query probably often before. It just means a compact URI, and the URI is, for example, a URL is a type like that you see in the browser up here. That's a type of URI, and a compact URI is basically a compact version of this URI where you have a prefix that is separated from an identifier part. So, for example, here's a bit of you can read through this by yourself, but you can have, for example, here you have like a URI, a person in the fictional person in the embl.org person database, which has as an identifier P9787869, and this could be represented as a person, as a query like this, for example. So we have a prefix. We chose here embl.ebi.person, and then the identifier part behind it. So the advantage of this is first of all, you know, if you work in data integration, you will see that URL type URIs, which is what is required by many of the formalisms that we are using, like RDF and OWL, are actually terrible like identifier schemes, because people forget to put the HTTP or HTTPS, or they have like slight variations of the domain part of the URL. So these are really not meant to be like identifiers in the strict sense of what we call identifiers, and it's much nicer to use something like a compact identifier form, where we can ensure that you know, it always looks sort of the same. So that's a long story cut short here, and you can read up about some of the ways that you can turn URLs into queries here in this section if you're interested. This is a bit beyond what we want to do today, but the important point is here that in SSSM, most of the time, not always, but like in 95% of the cases, we will use query syntax for denoting entities in our metadata. All right, so let's start with moving to how to create an SSSOM mapping set from scratch. One thing, for those that haven't been to a tutorial with us here, please, it's very important, just unmute yourself and interrupt at any point in time. There's nothing, it shouldn't be that formal. There's a lot here. That's why we are decided to teach it as a front tutorial, like a tour tutorial, but please just interrupt anytime, or if you don't want to interrupt, just chat, and then Nicole or Sarah or someone will just interrupt me and ask. But yeah, feel free to ask at any time if you have any problems or questions. All right, so let's start with how do we create a mapping set from scratch. So the first thing we generally want to think about is, okay, what is the core information that we want to gather, the core information that we want to curate when we are building a new mapping set. So here we are following the guidelines for a solid 3-star mapping. Here we have like this 5-star mapping system for mappings, with like increasing degree of let's say metadata. Now I'm missing the English word for this. Sorry, metadata. Not density. Anyways, with an increased amount of metadata, and this 3-star mapping is just like a very solid mapping that, if we would see this in the wild, we would be quite very happy. So the core data that we have to gather when we are building a metadata set, of course, are these 3 entity identifiers that we've talked about so far. So this is the subject ID, the predicate ID, and the object ID. Then we have one item that is called mapping justification. So for those that have followed the last changes to the SSSOM metadata model, so this is like a massive breaking change to the previous approach of the metadata, where we had another element which is called match type. So basically they mean the same, the values will be the same thing, but what this field means here is kind of any process or activity that led us to believe in that this mapping is correct or reasonable. So this could be something as general as, for example, human curation. So this is the process that led us to believe that this mapping is okay, or it could be a lexical matching on the label of the subject to an exact synonym on the object, or it could be a match on a common existing mapping or whatever. So there are lots of different mapping justifications. You can read in the specification what they are and what the most appropriate one is for you. In this tutorial here, we will just use human curation and that's it, but there are, you know, especially in the field of automated matching, there are quite a few distinct ways for describing mapping justifications. And then we have basic provenance metadata, so things like mapping date. So when was the mapping established? Author ID, who established the mapping, the mapping set description. So what is this mapping set that you're curating about? All these things we will go in more detail, like why they are important later in the tutorial. I'm just going to read this out now here, and we discuss some of them with concrete examples later. License, an ID of the whole mapping set as opposed to an ID of an individual entity in the mapping. The source of where does the subject come from, for example, which ontology does it come from, which database does it come from, the confidence, what's the kind of level of certainty that you have for this mapping that you've established to be true. And here in this tutorial, we are also going to gather some convenience metadata, which is subject label and object label, which has nothing to do with the mapping, but it helps us to read the metadata, the mapping metadata, a bit easier. All right, so let's start with the actual problem. So the scenario here is you are charged with aligning your organization's Foodie Inc. internal database about food and nutrition with the food ontology foodon. So in your database, you have a bunch of food items in a table. So for example, you see something like this. You have F001 apple, F002 gala, F003 pink, F004 Brayburn, and you know these are all kinds of apples. So there is a word for the general kind of apple, but these all here are actual, what are they called? Not breeds, but some word like that in the agronomy sector. I don't know, I don't remember. But in any case, that's the kind of information you have in your local database. And as a first pass, you want to just, you know, get all of these linked to foodon for the foodon ontology terms. So before we start, you should always kind of think about like what's the best way for you to curate your mapping. So one thing that we found very useful so far, but by no means the only way to do it, is to create a Google Sheet where you basically just have this SSSOM mapping table as a table that you can work on collaboratively with others. So this is, you know, one of the things that I think that is very important to think about when you're dealing with mappings. Mapping decisions are usually quite controversial, and you should kind of think about the aspect of curation and collaboration a lot when building your infrastructure for your own mapping problem. And then optionally, you have also the SSSOM toolkit installed. You can read about how to install it in the install instructions on the SSSOM toolkit website as well. So we don't need this today, but or maybe, you know, we don't necessarily need it today. Let's see if we get there, but the focus here is on just, you know, thinking through creating a mapping set manually. All right. So we've decided before about the kind of metadata that we want to collect. So that was the first step. We decided, yeah, this is the sort of metadata we want to collect. So what we will do first is we will create a new table. So I'm going to do that now here in Google Sheets. Call it mapping tutorial. I'm going to share it with all of you so that you can also just look at it if you want. Cultivars. That's it. Okay. And so now that I see, Harry, you had a question before, so it's great for mapping subject object area, but yeah. So that's yeah. So in this case, so we don't have any notion of mapping entire mapping sets to one particular, let's say, general class. Probably in this case, this would be one of these cases where actually the mapping in the BioLink model would, sorry, in the LinkML kind of based models is probably a more appropriate place for mapping. You would in SSSM land create indeed a row for every single OMEM ID and link it to whatever specific general category class you wanted to use. But just as a word here, so you don't really, so when we are building mappings, we don't really map to like to something like as general as BioLink disease usually. So when we are building mappings, most of the time we're thinking of mapping to a more or less exactly corresponding concept from one place to another. So this kind of like categorical mappings, they're slightly, different. You can use SSSOM files for this kind of task as well. But there is actually an element in SSSOM which is called subject category and object category, which is used for, which is used for documenting the type of entity that you are mapping. For example, you would have OMEM ID 123 and as a subject, and then you would have BioLink disease as a subject category. So it's different from what you're saying, but right, this information would be documented slightly differently.
Okay, yeah, that makes sense though. Thanks.
All right. Okay, so let's see whether
Nico, yep. Did you mean to share the Google Sheet link in the chat?
Yes.
Can you try it again? Because you pasted the Zoom link instead. Perfect. Thank you.
So now I need to see. So that doesn't work. So I will do it manually. I could just copy it from my actual example that I worked before, but why not? Why not do it slowly? Actually, can you, who volunteers here to curate the columns from this example here in the tutorial? So you can just, you see these are just 5 columns. Just speak up and you can just add these 5 columns in there. And I will add the actual IDs from the apples in the meantime. No one?
I can do it, Nico. This is Bradley.
Right. Thanks. Okay. I thought I could.
Actually, do I need permission to do it?
I'm just going to open this. No, I'm just going to open this to everyone now. It doesn't really matter whether you destroy it or not. So, okay. And I think, yeah. So now you should be able to just edit it. All right. So while Bradley is still curating the column headers, so now I have to be a bit careful with the. I'm going to, okay, so that's it. All right. So now what we've started basically with a simple thing. So in usually you would have some kind of data engineer that would give you a dump from your database that would provide you with a list of all your subject IDs and potentially with the labels. So let me just say a few things about the information that we have here so far. So the first thing that you notice here is that in our raw data, so when we were when you were looking at the relational database we were mapping, we actually had as identifiers F001, F002, F003, and F004. So now what you see here in the subject ID though is we have like a prefix colon these identifiers, and this is one of the kind of like very key and important concepts that that you should kind of internalize when you are building mappings like that. We want, and that's one of the aspirations of SSSOM and generally many or most of the semantic web adjacent standards. We want our identifiers to be uniquely and globally, globally unique. So we want to make sure that if you, for example, share this this mapping set here within your organization, and someone else interprets it, that they know exactly what identifier you were actually referring to in this column. So if you had F001, it's very possible that even in an organization, like if it's a private organization or if it's a public organization, doesn't matter, that this identifier refers to many different things in many different databases. So you don't know whether it's globally unique at all. So what you want to do is you want to create a prefix for it. And that was what we will look at later. We want to make sure that this prefix is also namespaced so that we know exactly what table and what information this identifier here refers to. Now, for the subject label, as I said before, this is one thing that is very optional. So it doesn't do nothing to the mappings, whether you curate a subject and an object label, but generally, in particular, when you are curating mappings that are meant for human consumption, or when there has to be a debate about mappings, and when people have to just quickly take a look at them, it makes total sense to just curate the subject and object labels as well, so that people can actually see what is being mapped straight from the table and not have to rely on automatic tools to do this for you. So that's why we recommend to always curate subject and object label at least. All right, yeah, thanks for adding all these columns. Okay, so so the first thing that we generally do, that's more like also from like a curator perspective in obo land, let's say that's your task. You have gotten the spreadsheet, you're supposed to map this, and we have like a bunch of people just sitting here in this call right now that have tasks like that all day, every day. And so what do they do? So there are many different options. So for example, one thing that you could think of is you could go and search the various search engines that are relevant to your area. So one option would be here. We are looking, for example, we're searching OLS for the Apple concept. So remember, we try to map. So let's try to map this first thing, the first ID, which is Apple. And then we just see, okay, what kind of results do we have here? We will look through it. Okay, we find some information, and then eventually we decide which of these results here is the most appropriate for us. So there are various kind of interesting concerns that you might have here. So for example, one thing that you will see is when you're opening the Foodon ontology is that there seem to be like at least 3 potential matches here for our Apple project. And this is where like mapping starts being really, really complicated and hazy. So we have on the one side, we have the Apple food product, which is one thing that could be useful for mapping our Apple. We have this Apple whole or parts concept, which could be useful, and we have this Apple whole concept that could be useful. So now, how are we going to decide which of these three is the appropriate thing to map to our database concept for Apple? Now, this is really like one of the really often very mistaken issues in the area of mapping, because the answer to this is there's no answer. There's no really good answer to this. So what you want to do is, in this kind of scenario, is you, first of all, you get really aware of the reasons for why you're doing this mapping. Let's skip this for a second, but then you will also talk to the various data experts of your database and ask them, like, what's the intention of this identifier? Like, what is it supposed to be representing? And they will then say, okay, we have, like, let's say a database which is concerned with apples, but we have various sliced apples, we have various whole apples in there, nutritional information about them, and so on. So it's going to be really hard to figure out which one here is the appropriate one to link to. So for convenience, right now, we will link to the Apple whole concept. We will circle back on that later, but we might as well have linked to Apple food product or Apple whole or parts. There's no like 100% correct answer at this point, which one to use. All right, so I'm going to document this now here. So I added now the identifier, and now what I will do is I will also add the appropriate predicate here. So this is I don't know whether I explained this. I think I explained this in the tutorial as well. So our goal from the side of the scenario is to find the corresponding exact matches from our database concepts into Fudong. So that's why we are mapping. We're trying to get exact matches as much as possible. It is not always going to be clear and whether this is really an exact match, and there are other mapping properties like broad matches and narrow matches and so on, and we can fill an entire session about which ones are appropriate, and we will see some of the concerns later. But yeah, so the first one, we've just assigned an exact match to this Apple ID, and we will also document the label here of this just to keep it here. One thing, I think I wrote it in the tutorial as well. I do not remember everything I wrote exactly in that tutorial, but I just don't want to jump back and forth all the time. But here we keep in mind the fact that maybe there is a better match in Apple food product. So we can document all these kind of design decisions here as a comment for lack of a better solution. And I can only tell you, like, I know that computationally minded people, they typically skip things like comments in when they are curating things like that, but it's super useful to just write down exactly your concerns and your thoughts and just add them as a comment, which is part of the mapping model. And here in the confidence, so because we had this kind of like concerns that maybe this Apple here may not be exactly the right one to map to, because it could be Apple food product, because we know we are also concerned with sliced products, we're not going to give it like full confidence. We're just going to give it some lower confidence. I would just give it 90% confidence now, which is pretty random. All right, so now next step, we have the Gala apple. Can I ask maybe one of you to just volunteer to just go through the process of mapping the Gala apple? Just, it can be wrong or something. Just what will you do next? What's the first thing you do? What will you write where? Just, yeah.
Yeah, I'll do that.
Awesome. You can just speak. So
All right. I'm sorry. I'm just trying to find my place here. Okay, so let's see. Let's just assume we've got another exact.
you want to actually share screen then?
Oh, sorry. I realize I don't actually have access yet because I had not refreshed the tab and needed to sign into the different account. There we go. Okay. So yeah, let's share. Okay, so I've got a Gala apple. Let's assume that I do have an exact match in Foodon, and just for fun, I'll pop into OntoB. And see. Gal apple. Okay, Gal apple is in fact in Foodon both as itself and as a whole apple, but this one looks pretty good. So we've got a query for that, or at least an IRI that we can turn into a query. Make that Foodon. And that was Gala apple whole. And I am 100% confident about this because I don't think there could have been a better match,
Right,
than this. That's
cool.
That's a true exact match.
I think that this is a very you described it perfectly. So I just want to make one comment here on your process, which is very important. This process of turning the URI of Foodon into this query syntax. So what you've seen Harry do before is because on the OntoB page, there was no obvious way to simply copy the query from there, or maybe there was, but we didn't see it. But this is very often the case, actually. So what you do, for example, when you're copying from the browser, from the URL bar, or in many cases, you would just see this. So what people do is they copy this last part of the URI, then they paste it into in whatever field they are pasting it into, and then they think they're done. So I still see this happening very, very often. But this is actually, as you know now, this is not anything. This is just what you would call a URI remainder, and this doesn't mean anything. And there used to be a concept for this in obo land, which I hope that no one uses it anymore, which is called short form. But now we just use either the whole URL as a URI, or the query, which is Foodon with a colon and then the identifier part. So that's very good. Anyone wants to make a comment about this mapping decision here?
So there is a question in the chat, Nico, for you.
Okay. So the question is the confidence something that is actually defined? Is there capacity for annotations on it? Yeah. So there are a few other So for example, we have a few scores in SSSOM that denote things like similarity and things like that. And this is a better place to extend than confidence. Confidence really is just about the degree of belief in that this mapping, according to this particular process that we are in, is a true mapping. So I wouldn't try to extend this to anything, but there are scores that could be extended. Yeah. It is very, like, it is subjective it isn't, so Alan says subjective versus objective. So confidence is a complicated thing in this sense. So confidence obviously is a very subjective score when you're in, like we are now, in a manual mapping scenario. Now then it is very subjective. It's literally an interrogation of the curator in their own mind to figure out, is this really what I believe, and do I have concerns? But there are very objective ways to determine confidence when in automated matching algorithm. So for example, you could say that if you could define a confidence level over something like some kind of combination of string matching and other automated procedures, and then you have like a clear rule that leads you to believe whether that leads to a confidence value. So that in this case, you would you could say that it's objective in some sense because there's a clear rule that can be defined and not just, you know, an interrogation of one's personal feelings. But yeah, generally it's very hazy. So it's definitely nothing I would, the confidence, you will find it very often in SSSOM as a concept. We use it everywhere. Also not just on here on mapping level, but also, for example, when we build repositories of mappings, sometimes we trust mappings from one source. For example, Mondo, we trust them more than from another source like UMLS. Then we will attach a confidence value to the entire mapping set. All of these processes in the end are a bit subjective, I have to say, and I trust these confidence values only so far. So yeah. But hopefully that answers the question, not very well, but a bit. Okay, good. Anyone else wants to do ping? It won't continue without someone volunteering. Yes. Shall I start asking around? Maybe
I can do pink, but
okay.
I am curious about Brayburn because I already looked up both of them and Brayburn's not in there. So
yeah, that's good. Perfect. Let's start with pink and then we move over to Brayburn, and someone already maybe that's brave enough can think about Brayburn later. Okay, yeah, Ellen, if you want to share screen and we do pink, then that would be cool.
okay, hold on. All right, so I went ahead in OLS because I really like the way OLS is set up, and went into the food ontology and looked up Apple, and then basically, oops, sorry, let me go back because I already jumped ahead. So looked up Apple, and you see all the varieties that are currently in Apple Whole. So you see pink or pink whole raw. So I guess, you know, here's a possible interpretational thing. I could go directly for this, which has that food on ID, or if I went here, you know, it would have a different food on ID. So kind of depends on how specific, I guess, you want to go. So I'm gonna actually go down into this one. And what I like about OLS is you can just copy the ID right there, so that, you know, if you do need to do that, it's pretty easy. And you can just copy and paste that for the ID. So I guess for this, I guess I missed that a little bit. Would you say, I mean, I would think this looks like an exact match to me, but how is this column pulled out again?
So I guess this is the key here is exactly this kind of question. Like if you feel like you're matching on the same level, so if you're matching something that kind of corresponds to each other, then yes. So our goal is actually here to build exact matches, but as far as they exist. So it's kind of as part of our use case that we want to create exact matches. If you were like in Mondo land, where our goal is to map absolutely everything to each other, then we would have to be more careful with exactly the predicates. Actually, not more careful, but you would see more cases where you have broad matches or narrow matches and things like that. So now our goal is to get an exact match. You made the choice of map that the whole raw is an exact match, which you can justify. You've talked to your product team. The product team, yes. All of the nutritional information in our database is about raw apples, so you're fine with that. You are also very confident about it. But then, you know, in this case, you could also again argue, you know, why didn't we map to the pink apple whole? This is kind of, it's always this kind of problem that both of them could be fine. So, for example, when I mapped this, I argued for pink apple whole instead of pink apple raw, just for the reason of retaining consistency with the other mappings. So the other mappings were all like to whole things. So I decided, you don't need to change this now. I mean, this is like this is maybe a super simple example, but when you are doing in real world, when you're mapping diseases, you are not going to see whole and parts in brackets and can make such decisions so easily. So it will be much more complicated. And
Nico,
yeah,
sorry.
go
I
ahead.
was going to ask, I don't see information stating whether it's raw. If I had to make an assumption, I would assume it's raw, but I don't see any information indicating that it is absolutely raw. So I would err to the side of picking pink apple whole, not to maintain consistency, as you said, but just because of lack of clarifying information.
Yeah, that's also like, that's another good argument. If the use case, so I don't remember exactly what the use case description was saying, and whether the use case description was saying that we are talking definitely about raw apples, and in this case we would then this would change the situation a little bit. But yeah, you're right. Like if the our scenario currently doesn't actually give enough information for this, so I would also err based on this to map to a more general term, which is whole. Yeah, but
I also have another question. When you are building an ontology like this, having these qualifying terms like whole or whole raw, or maybe whole cooked, or like adjectives for these things, that seems like not necessarily, in my own opinion, best practice to do that.
yeah, it's a very good point, and one that we are definitely not going to discuss now, because it's like it's one of the big
I mean, given that I've been working with Uberon and CL.
Yes, yeah, we want to avoid, so in most cases we avoid this.
Yeah, I was gonna say, this just strikes me as just like a rabbit hole you don't want to go down.
Absolutely. No. Because you have to imagine, like if you have whole or whole part raw, then you would have to kind of materialize like thousands of different classes for each and every kind of cultivar.
But the other thing too is whole and part can be described as relationship type aspects as opposed to.
Yeah, the Q could, exactly, to avoid creating precomposed terms. Yes.
Yeah. Okay.
I think this would come a little bit in like the brain side, right, where you have sub layers and things like that, and mapping that becomes a little bit tricky. And I think that's kind of where I find this example a little bit interesting. So for example, if I want to say layer 2 of the visual cortex, we don't technically in Ubron, I think we've made a decision to not, for example, put each of these terms as individual things. And so I guess that's the question here. If it's, I'm assuming that in the SSSOM, if you say that it's an exact, that means it's an equivalent, right? So that class is equivalent to the class that you're mapping it to.
So this is a bit of, again, a very hazy situation in mapping land in general. So we remember that on the left, the source of our mappings is not an ontology. Yeah, so the word equivalence doesn't make much, conceptual sense. So it does make, so I think that it would be a bit of an Yeah, I don't think that this distinctions of equivalent and exact match in this case is very helpful for your mapping process. So what you think in your mind is that these identifier refer to the same real world object. That's kind of the thought process that goes through your head. So that's all. And if it's for me, the logical equivalence, when you're talking about owl equivalent to, is something slightly different, because it sort of relates also to your conceptualization. So you can only have two classes being equivalent to each other, not only if they refer to the same object in the world, but also they must have the same logical axiomatization underneath, which in this case we don't have.
That makes sense.
Yeah. So and for this other problem that you just stated, where you want to map composed entities, and where you need to map composed entities, like, you know, where you don't have an exact counterpart, where you actually have to say raw and whole and all this kind of stuff. This is also something that you don't want to do right now with SSSOM. So SSSOM scope is really about simple terminological mappings, and you can't reflect complex mappings like that in SSSOM at all. There are issues open for this and many proposals, but no one has solved them so far.
So maybe this might be a stupid question, but what exactly then is the SSOM file materialize, I guess, a bad word. So for example, if I'm mapping two things together using SSSOM, how does it actualize itself in the end? So for example, in the bridge file, you can merge them together and become an ontology, right? What does SSM, because you said that's not like the equivalence kind of thing, like in, say, a bridge file. I was just wondering if,
So I think you should think of, when you're thinking about mappings, you should think more about data than about ontologies. So we are not creating a file representation for axioms or something. We are creating a representation for linking entities together, and what the application does with this, the application needs to figure out. So for example, in one project that we are using right now, we have a mapping between a terminological system called OMOP, which all our patient data is linked with on the one side, and we have ontologies from OBO on the other side. We decide to put SCOS exact match as the link between them. Then we just transform this into sparkle triples. So we just see a sparkle, like literally an RDF triple between the subject and the object. And then you can simply run a sparkle query to get all of the patients that had a cardiovascular disease or something according to the ontology. So that is one way these can be used, these mappings. You should not think of them as axioms in an ontology, like similar to the bridge files in Uberon. That's different use case.
Yeah, I mean, that example was really good. I think I understand it quite a bit better. Thanks.
Thank you, Sean. All right, let's go quickly to the Brayburn. So if you, even if we don't get to do all of this stuff now, so you can read all of the different details here in the tutorial. So as Alan said before, there is no Brayburn in Fudong, so we have to make a choice again. So this is one of the key pieces, the key places where you want to make, where you have to decide, for example, whether either you decide not to map this term at all. So that's always one valid decision. So you can say, just do not have a mapping for Brayburn, or you can map it to the next best thing. So in this case, you could decide that, for example, if you have like a use case where you want to hierarchically group data in your database so that you can query it according to an ontology, sometimes it's fine to just create broad matches in your mapping set. You would be happy with this. So for example, you could here, you could decide that for your use case, you want to make sure that if you are querying for all vegetables according to Fudong, or all fruits according to Fudong, that you get your Brayburn back. then you could decide that you map Brayburn in absence of Brayburn existing anywhere to, for example, the Apple concept. So you would say, okay, there is no exact match, so I will put a broad match instead, and then you you just say, okay, this is a broad match, and this is to the whole Apple. So that's one possible way. Another way for some use cases would be just to simply go and create a negative mapping. And I give an example in the tutorials as well how to do that. But in this scenario here, because our use case is group information in our database according to Fudong, we decide that broad match is the way to go. So again, there is no rule here that can tell you this is how you map this term that doesn't exist. You have to always be aware this is the use case that you are trying to solve. This is the target solution that you want to apply, that you want to do with the mappings. And for this use case, do you want to map broadly or do you want to exclude the mapping? So if your use case, for example, would be data translation or transformation or changing one data set to another, then it might be safer to not include broad matches at all and just keep just say that there is no corresponding mapping for Brayburn. And yeah, and then that's it.
Sarah asked if you can match to the hybrid parentage, like Brayburns are a hybrid of Lady Hamilton and Granny Smith.
Oh, so yeah, this is an interesting question, and it relates a little bit to the question before about complex objects and subjects. So as you realize, the word simple in SSSOM is one of the most contentious things on the in the entire design process and with the community that we have. And this would require saying that this is a hybrid kind of Apple, this would require us to have a way to express what we call concept expressions. So you would have to say something like whatever these two apple kinds are in the object ID, so apple kind 1 or apple kind 2 or apple fused with apple cultivar 1 fused with apple cultivar 2 or mix of or something like that. You have to express that as an expression in the object ID. This does not exist in SSSOM at all at the moment. So you don't want to use this at the time being for such complex mapping processes. So I see just some other questions. So yeah, but what you could do though, alternatively, just to be clear here with the Brayburn, what you can do is you could fake hybrid parentage a little bit by simply using creating two close matches from Brayburn to both of these hybrids. For some use cases, maybe this may be useful, but not for the one that is described here. So there are some decisions you could make here by just creating two separate rows in your mapping set to both of these, having two narrow matches to these, for example, hybrid apple kinds. But yeah, I don't know. I don't think I would have to think this over whether this is really a good idea. Definitely not for this particular scenario. All right, we have only a few minutes left. I just want to quickly browse through the remaining parts of this process here so that you get the full picture. So we have now curated the entire mapping. So you can see here in the tutorial solution, we have decided to actually document that there is no exact match for Brayburn, but we also have a separate row for the Brayburn to the whole apple as a broad match. And now what we want to do is, I'm just going to skip through some of these things. So this here, you can read through this. It will explain to you exactly why which piece of metadata that we want to curate additionally is very important and for what reasons you should document them and how. But I just want to emphasize here. So there's sometimes this kind of question of where metadata should go. So should metadata be put basically as a value in the columns here as part of the mapping metadata, or should metadata be curated on mapping set level? So if you have looked at SSSOM mappings before, you will have noticed that many of these SSSOM mappings, let me see the smaller one so that you can see it. And let's say this one, have this sort of header part in the table where you can see, for example, the query prefixes declared. You can see mapping set level metadata, like this is the license for the whole mapping set. This is when the whole mapping set was created. This is where we derive the mappings from. This is the mapping set ID. This is the tool that was used for computing the mappings, and. So this kind of information can be documented in SSSOM as global metadata for each of these mapping sets. And then, so in a real kind of scenario, what I would recommend, you would have kind of a table like this. Then you can curate your mapping set level metadata as a, sorry, this is all a bit rushed now, but I just wanted to be sure to mention it. You can curate this as like a little YAML file that you just keep as a file on your computer that looks like this. Like it's just like a bunch of values with columns with values, sorry, keys with values. And then you can just use the SSSOM toolkit to just merge this table that you curate on Google Sheets with this this global metadata for your entire mapping set together to produce a full integrated SSSOM mapping file that then looks like this. All right. Okay, let's look at another two questions. So there's no assumption that a subject is unique in a given mapping set. No, there's no assumption like that. No, there's no. You can have each subject can appear many different times in a mapping set, and indeed, one of the key use cases here for the confidence is that you can integrate mappings from many different sources, merge them into one big mapping set, and then discard all of the mappings that have lower confidence levels attached to them. So these kinds of things are very important use cases that we address with SSSOM. So yes. Having the same ID in the same mapping file is definitely possible and will happen quite often. Any other questions on the tutorial? Any wishes for more clarification, maybe in the future or now? Awesome. So thanks.